Good afternoon, everyone. Thanks very much for coming to today's session. So using AWS to meet requirements for HIPAA, FERPA, and CJIS. To start things off, I want to talk a little bit about something that I've heard some folks ask about this session, which is HIPAA, CJIS, and FERPA are three different compliance frameworks that don't organically go together, and that it doesn't seem like a logical pairing of them. One is student information, one is healthcare information, patient safety, patient data information, and one is dealing with law enforcement. There doesn't seem to be a clear overlap between those. And really what we see is that if you actually break down how the fundamentals of each of these frameworks works or compliance packages work, is that there's actually a lot of shared overlap and crossover between these, and I want to kind of share that with us today. For folks that don't know, with AWS, the way that we're able to achieve the security and compliance frameworks that we have is through our shared responsibility model. And what that really means is that basically AWS is responsible for the hypervisor on down, and you as the customer are responsible for the hypervisor up, so the software layer. So the reason that that's important is because sometimes we hear that customers in all of these frameworks sort of say, oh, well, you know, I'm on AWS, so I must be HIPAA compliant. No, you know, if you create an application that's poorly architected and has a default login of root password 1234, that doesn't excuse you from your duties to design your application safely. So with that, I want to introduce our panel members today and let each one talk a little bit about what their organization does and their compliance package. And then we're going to dive into some Q&A that I think for you as the audience, if you're here, most likely you're interested in one of these compliance packages or frameworks. And what we want to try to address is how do you actually start to deploy a workload on AWS with one of these compliance frameworks. So I want to start off with Gerard Gallant. And Gerard works with Motorola Solutions Group, and he's representing our CJIS.
Good. I guess it's almost evening now since it's 5:05 p.m. Gerard Gallant here. So at Motorola Solutions, we're in the business, among other things, of assisting public safety agencies achieve their mission in the United States and across the world. One of our newer offerings that we have is around the world of public safety data. Data is exploding in public safety just like it is in most industries, and we've created solutions around our intelligence-led public safety space, which is basically taking data and creating intelligence out of that data to help public safety agencies achieve their mission. And you think, well, what data would public safety agencies have if you're not familiar with them? 911 calls, 311 or non-emergency calls, video data, that's both body-worn camera data, fixed video camera data, in-car dash video camera, non-emergency phone calls, text messages, crime data, history data, records management systems. There is just a plethora of data. And this day and age, you don't solve a crime or you don't prevent a crime without having data. Data is power, and it is what a police agency uses to both prevent, detect, and prosecute crimes that may happen. So with that massive quantity of data, you need to be able to manage it and intelligently understand it and use it to predict what may happen in a given area. When we first looked at creating cloud-based applications in public safety, from our long history of on-premise applications, our first application we chose was based on digital evidence management, which is a combination of our video management software and our really differentiated body-worn camera. It's really more than a body-worn camera in that it's actually a video speaker microphone that combines not only the SI500, combines not only the ability to take video and still images, but also acts as an emergency call device, really differentiated device that's more than simply just a officer-facing camera. On the AWS GovCloud, we worked extensively with AWS to ensure compliance to the Criminal Justice Information Services security policy, which is a superset of the NIST 800-53 policy that is required for government agencies who are in law enforcement. So it was a short road and a long road, and we were very successful in working with AWS to ensure that the data that our agencies put in the cloud is secure and is available and reliable. And you'll hear that in some of the questions that we will talk about is security is great, but you need availability and reliability also.
Great. So I want to hand it over to Elizabeth Boudreau, and she's the Director of IT for Claritas.
Good afternoon. So I am the director at Claritas Genomics. We're a pediatric diagnostics genetics laboratory. So you may be used to going and having your blood drawn for your CBC or your cholesterol tests. We do pediatric diagnostics for disorders, primarily chromosomal disorders. We were part of Boston Children's Hospital. We were the genetics lab for over 20 years and spun out to be our own company. When we did that, we lost access to all major data centers. We worked with Harvard and had these massive compute, and we had nothing. So we moved to a new location. We were still looking for real estate when we incorporated, and so when I needed to have a place to do our work, but no idea where our work was going to happen. So we went all in AWS. We were the first company to sign the BAA with Amazon. The business associate agreement, I personally helped do some red lines on it, so I know it pretty intently, especially around the shared securities model. We have found incredible success using Amazon. So most genetic tests, if you sent out your sample for your kid, 3 to 6 months to get a report. Now, when you have a neonate who's just been born with a disorder or your kid's sick, who wants to wait 6 months to hear a maybe answer? So with using computing and with speed, we do our test results sometimes down to 2 weeks, but our average is 4 to 6 weeks. Our record is for a neonate patient, we did it in 7 calendar days. So imagine going from 6-month wait period to 7 days for an answer for a sick kid. It's a pretty amazing thing. We are completely all in. Everything we use is Amazon. We have multiple services. We make big data as well. Our genomic set, it can be quite large. We move that data. I have 0 servers on site. I have a whole bunch of lab instruments and then a direct connect that gets all the data out and goes straight to the cloud. So everything we do is on the cloud from that point on to a data delivery and a report for a physician. Look forward to explaining a little bit more of why I think this is a great thing. I think friends don't let friends build data centers. It's not my line, but I love it. And just thinking about how you can move it over without being afraid of it, because I think you actually gain more in the cloud than you think you do around security and HIPAA compliance. I'm also the HIPAA privacy and security officer, so it is my soapbox to make sure that we are doing things appropriately, and I'm not going to have an auditor knock on my door at any time.
Thank you, Elizabeth. And then Frank Chen, who is our FERPA panelist, and he's with Coursera.
Yeah, hi. Hi, everyone. I'm Frank. I work for Coursera, so some of you might have heard of us. We are an online education company that's founded in 2012 by 2 professors out of Stanford. And our mission is, of course, universal access to the world's best education. So we have a public site of our company where we deal with 22 million registered users, 140 university partners providing content and so on. And on the other side, some of our instructors on our platform also want to use our platform to improve their on-campus teaching. And that's where FERPA compliance for us comes in. Because once we start integrating with, for instance, using SAML to integrate with student information systems, once instructors start importing grades, uploading quizzes and asking students to take quizzes on our platform, then we are dealing with student grades. So these are obviously covered under FERPA. So universities always have concerns about privacy and security and where you get hacked and things like that. So we are also born on the cloud. So we were founded in 2012. We started with Amazon, and it has been very good to us. And I look forward to telling you guys more about what we do for FERPA compliance. Yeah, thank you.
Great, thank you very much. So I'm sure that there are some folks in the audience that maybe are new to the cloud or are figuring out how they want to approach working in a relatively sensitive environment. And I want to kind of take that head on to start with by asking, for all of your frameworks and all of your compliance requirements, there are naysayers that essentially say the cloud is not secure, that we can't deploy our workload in a way that would be as safe as it is on-prem. What would you say to your peers that say that?
I'll start. My big philosophy is, what is your core competency as a company? In healthcare, my job is to make sure we get people better and to do better care. It's not to be a data center. So when I think about even my time at Children's, we had a data center, but was that the best use of our resources? And could I walk into that place? What kind of controls were we doing there? I feel like by moving it to the cloud and being able to outsource part of it, of the shared responsibilities model, I'm able to focus on what my core competency is and really use my resources appropriately. We were a startup, so I didn't have a big load of cash or FTEs to be doing this. So we really had to shoestring it along. And I knew that the cloud could help us do that faster, quicker, and more efficiently, but keep us secure. And I wanted to make sure we were using everybody the right way. I think as we talk to other companies, especially around healthcare, where's your data? Well, in the data center. Well, what's the difference between saying in the data center, in the cloud? I mean, I know I can call Amazon and say, give me your SOC report. I don't know that I can always call the data center that was in Macolo or hosting some of my resources and getting reports like that before. So you definitely gain a lot more around the security framework, I think, with the Amazon and cloud model.
I guess, and for public safety, it's a bit of a different animal because the cloud is so new. A lot of public safety agencies are dabbling in cloud technologies. There's a lot of skepticism. Is it really secure? And having spent the last 5 years architecting and helping move our solutions to the cloud, I can absolutely say that the knowledge of what is security has to be expanded. In public safety agencies, a lot of people think of it's got to be CJIS compliant. And they think of a couple of key things. They think of personnel security and some training and some documents you have to sign. Well, in reality, the number of security controls you have to implement is pushing 500, 600 in that range. And if you only focus on the most common ones, you're really missing the boat. So by being able to partner with AWS and take care of the easy ones and then add in all of the technical controls that allow you to audit and allow you to monitor the systems, add in, even the physical controls at an Amazon data center versus an on-premise system, they're at times in two different ballparks. The ability to protect the data from the outside at a big corporate data center versus at a local on-site data center or computer room in many cases that may be in a basement in a flood-prone area. So I guess to summarize, I would suggest that we've come a long way. There's a lot of education involved, and I would look at security and also look at reliability and availability, because you can have the most secure on-site system, but if you can't keep it up and running because your air conditioner fails, which happens all the time, then maybe your security needs to be rethought because you've just lost a whole bunch of data and you couldn't accomplish your mission. So there's a balancing act, and I really think that once people get educated and understand what can be done, and you look at all the aspects of personnel security, physical security, logical security, technical security, combined with a good compliance program, I think people come to realize, wow, it's pretty significant, and it does meet the test and does pass the control rules that exist for these agencies.
Right. I think I have the easiest job out of the three of us because a lot of universities do already run multiple workloads on AWS and other cloud vendors. So so a lot of our partners already have an idea of what security models are there and what is the shared responsibility model, for instance. And for those partners that are not that familiar with the cloud, for us, it is really up to us, up to Coursera, to basically educate our partners about my fellow panelists said about physical security, because sometimes we receive checklists such as questions on who can access our data center. It's like, I can't access our data center, right? So a lot of it is educating our partners and saying that the physical security is okay. The hypervisor is going to be patched, and supplementing that with our own internal policies regarding how do we respond to security incidents, how do we what our password policies are and what our IT control policy is, and so on and so forth. So for us, for us and for some of our partners, it's just about education and making sure that they understand what AWS can provide and what Coursera provides. Yeah.
Okay. So Frank, I want to stay with you for a second. So FERPA is one of the older compliance packages, and it was originally authored in the 70s. It is the most loose interpretation, and meaning unlike HIPAA, where at least there are fairly clearly delineated controls that need to be met. In FERPA, those aren't so binary. It's not quite so black and white. When you have customers like in higher education that give you those sorts of checklists looking for things like, do you have XYZ control? How do you speak to those customers? How do you sort of attest that you're actually able to meet that bar?
I think a lot of it is that you are right that FERPA is written in the 1970s, and it doesn't have and it just mandates that you must protect student privacy and you must protect records. It doesn't really mandate how to do it. So what we are looking, we do is that we look at Department of Education guidance in this area. So the Department of Education has a Privacy Technical Assistance Center. So they have a very nice website that they keep updated, and they state regarding what password policy you need and what data center security things you need and so on. So we point out our partners to that website, and we also point out partners to, for instance, the AWS security white papers and the AWS, shared responsibility model white papers to, check some of those, for instance, physical security items off the list. And of course, other things like, how do we separate logic, how do we do like logic controls, how do we respond to security incidents? Of course, that's up to us. But for a lot of those things, we point to AWS white papers, which are very extensive. Yeah.
Great. So in addition to the standards laid out through your compliance package, so Gerard brought up that CJIS has NIST 853. Are there any other compliance packages that or frameworks that you use to better harden or safeguard each of your policies? Do you look to any other standards other than, say, NIST for guidance on how to properly configure an environment or how to properly configure a workload?
I mean, I would say we use NIST 853, and those of you who don't know what NIST is, National Institutes of Standard and Technology, publication for federal information processing controls. It's a very, very boring document. It's really long.
Very exciting. He's wrong.
It's like you could wipe paint dry with it, but it is the gold standard for federal systems. And when you actually look at the controls, they make sense. There's nothing in them that are really, really odd or ugly. CJIS is actually a superset of that. So it takes NIST controls and adds selective controls to them. For those of you familiar with the federal government FedRAMP process, it is a subset of NIST 853 controls, 3 different baselines. What we tend to do is we treat everything as if it's CJIS data, whether or not it is or not, because one of the uniqueness of the CJIS policy is that customers may choose to enforce it for data that's not technically defined as enforceable under it. So a customer may say, my data for records management, which will have no FBI data in it, will be subject to the policy. You don't have any control over whether you agree or disagree. You must just implement it. So what we do is we treat everything as CJIS data. And in terms of additional standards, we tend to follow some of the ISO standards. We also follow NIST standards for incident management and control, and some of the NIST cybersecurity framework publications that are coming out. And likewise, because we're in the government space, a lot of the FIPS publications for encryption, FIPS 140-2, which is, again, referred to and mandated by CJIS, but we use that publication for our encryption standards because that is a requirement.
Since we're a laboratory, in addition to the HIPAA stuff, we also have to be an accredited laboratory. So we have chosen, instead of CAPA, we're an ISO accreditation, which we found when we did our ISO accreditation. There's some very minor things about data retention and result retention, but they had no idea what they were doing. These are people who are used to lab instruments. They had no idea cloud data center. It really came down to the auditor saying, so you keep it and you can get it for 7 years, right? Yes, we have it available to us. So we're finding that even though we're HIPAA, similar to CJIS, I've taken the philosophy that everything we do is PHI. Genomic information is not PHI, which really it's your ultimate PHI. But under HIPAA, genomic information is not covered. Your date of birth is, your CBC result is, but not any of your genetic testing. Digest that one for a minute. So with that, we really think HIPAA will evolve at one point and take genetic information into account. So we just off the bat as a company took it into account. So everything we do falls under HIPAA. I know you'll go to multiple sessions, it'll talk about account, single account, multiple account. We actually run a single account environment. And so I run one HIPAA account. So nobody can play with anything else in another sandbox and put it in my HIPAA account by accident. It's one and one only.
Yeah, like the other two panelists, Coursera treats everything as basically student PII, and we protect it. Like we protect your, if you're a public customer, we protect your data to the same equivalent strength as we do for our on-campus students. And as to frameworks and so on, we don't have we don't really have a lot of frameworks required for FERPA, but we do look at the NIST 800 series, which is a lot of documents. Some of them don't apply to us, but one particular document that I want to call out is 800-122, which is protecting PII. So that is actually because that's what we do, right? Protecting PII. So that is a document that we refer to quite a bit. Yeah.
Great. So Elizabeth sort of segued perfectly, which is. There are data sets that are not really bound by compliance until something happens, right? So for HIPAA, it's genetics, right? And as Elizabeth has pointed out, it is sort of maddening that it really is the most sensitive piece of information that you have, not only about yourself, but all of your descendants, right? Everything about you and your ancestry is actually in there, and it's very, very private if you really think about it. And much the same way for Gerard, people think, oh, well, body cameras, that must be, subject to CJI, and not really, right? Not until it actually goes into a case or it's actually used as part of evidence. Up until that point, it actually isn't. So to that end, can you talk a little bit about how it sounds like each of you have sort of established that we're going to treat everything as restricted data from the get-go. Do you do anything to quantify or tag or otherwise identify data that may or may not be subject to greater scrutiny or to a level of the compliance package?
We don't really change around compliance. We change lifecycle policies for data retention because different types of data have to be restored for different periods of time based on what they are. So it's a laboratory. We have raw data, and then we process the data, and then we report the data. Those each have different lifecycle and lengths of retention policy. We are pediatric, so anyone under 21, if you don't know, you can sue up until your child's 21. So in my life, it means I keep those reports forever because previous to AWS, you couldn't figure out what had been there for 18 years, 21 years. Now with our life cycle policies, it's great. I set everything for 1 year past what the regulation says or even what my policy says I will do. and then we are big fans of Glacier and disaster recovery modes. So really, when it comes to doing additional things, it's more around the retention of the data than it is around the security of it, because I need it secure all the time, no matter what year it is.
We tend to treat everything as criminal justice information because it's simpler, and the CJIS policy is a unique animal in that it, as I think I previously mentioned, it allows the agency to do that. It is a minimum standard. It's very clear. It's minimum. So if the agency says everything's going to be protected by this, then if you choose to design an application that doesn't do that, then you're in violation of the policy and you probably won't sell anything to that customer. So we choose to protect everything to the same standard. We do not tag the data. There are occasions where reporting systems, if they have been if the data's been aggregated to the point that it does not contain any criminal justice information, it's point information at a particular crime that doesn't have any names in it. We at times will put that in a non-CGI space, but you're asking for confusion with a customer if you start doing that in the cloud. In customer sites, we do it, but in the cloud, we've said it's just easier to treat everything in the same GovCloud instances as coming under the same security model, because you don't know when a customer may say, well, you got to treat it like that, and if you're not doing it, you're not going to sell it to them. So it's just cheaper and easier to do it all to the same standard.
Right. For us, we do tag data by by basically the partner institution, and that is really for like data retention, data deletion purposes, mainly because because Coursera, we have probably 2/3 of our partners are non-United States, so we not only have to comply with FERPA, we also have to comply with all this whatever the Swiss government thinks should be data retention, or data should be like your data retention period, or what the German government thinks should be your data retention period, and so on. So we do try to tag our S3 assets and so on with at least which partner this belongs to, just for data retention and data erasure policies. Yeah.
Yes, you raise a good point on data residency. Our material and customer data is stored in the country or aggregate country required by the laws of that country. So Canadian, we're waiting on pins and needles for AWS Canada to open when it will be stored in AWS Canada GovCloud. Likewise, in Europe, due to the very strict privacy and residency rules there, China, et cetera. So we actually will have separate instances. Data doesn't move across the rules that allow it, so we don't have to tag because it physically sits in the country it has to sit in to follow those data residency rules.
Right, we follow safe harbor regulations, or the successor to that, I forgot the name, but all our data is in the US, but we have to make sure that they are handled properly according to the laws of the originating university, basically.
So I'm sure many of you in your organizations today test and validate your security or your actual stance on security. So you have policies, and I'm very hopeful that all of you are actually testing your policies and testing what you have said that you're actually going to do. So for AWS, I have yet to run across a customer yet that has perfect security, and in fact, that goes all the way up the proverbial stack into the government space, right? So no one has it. And quite frankly, if anyone ever said that they did, I would run from them as fast as I possibly could, because it really is impossible to achieve absolute perfect security. It's a moving target. It's always shades of gray. So to that end, what we often see customers do is they try to do game days or red team or blue team type testing. And I was hoping maybe you could all share with us, do any of your organizations take a stance on actually performing evaluations of your security? And if you do, what kind of techniques do you use?
We're starting. We've moved more to a blue-green model, especially in our software deployment, snapshotting, copying. We're out of Cambridge, Massachusetts, so we're in the East region, but copying things over into West and doing failovers. We run primarily on Direct Connect. We just changed up our configuration. We have two 1 gig lines that we have 2 always-on lines, active-active, as well as I had developers who were in instruments that we separated the LANs for things going up. So we've done failover testing, especially around the network, to make sure that my data can still go up. Some of the sequencing machines, you get 1 run, and then it has only enough storage for that. And if you hit go on the second run, it wipes it out. So you've got to get the data off the machine and into a place you can use it before you hold up the next test. So I don't want my team the one holding up the genetic test of somebody else's patient. So we've done more around the networking failover and disaster recovery, more so than our software implementations or data recovery.
Right. So for Coursera, we use like third-party companies. Some of you might have heard of Synac. So they do like white hat testing. So before we launch a big product, we get them to do white hat hacking into our systems. Basically, they try to penetrate this new feature and probe and see if there are weaknesses. Besides that, we also have fairly stringent code review policies regarding new like how do you review code, what sort of things you are looking for, is this are there logical controls in this code that you are going to deploy to production and things like that. So that's what Coursera does. Yeah.
We use a combination of tools, automated tools to do complete code review. Likewise, in the incident response plan, which would be an interesting question to ask, how many people actually have one, a written, documented incident response plan?
Everyone's going to put your hands up, right?
Who has a written, documented, in writing, then you know where it is in Reddit, incident response plan?
Bless your hearts.
They're very hard to find. Good ones are hard to find.
I wrote mine, I finalized it, and we went down the next day. The ink wasn't dry, and we used our incident plan, so you need them.
I wrote ours with collaboration with the team, and we had 2 attacks, which we used it fully on. Now, luckily, those attacks were in demo systems, which didn't have any data in them. They were instances that were just play instances, and we used the plan and activated the plan as a test mechanism. It was as good a test as you're going to get, as opposed to doing a fake incident, because it was real. Luckily, our partners at AWS notified us of the illicit behavior that was happening on the network segment. But, that is in the plan, and we're actually in Q1 doing, I believe, a full-blown internal test of the plan, because our stuff just went live in AWS in April timeframe. So we've tested all around it. We've used the 2 incidents that we had in our demo environment, which, were, long story short, somebody just didn't configure them right. It would never have gotten through in a production environment because of all the controls that are there and the monitoring that happens. But when you have a demo environment that someone puts up and they leave it wide open, it doesn't take long to hack it. So it was a lesson learned. It's since been fixed, and much bigger controls on how those things get set up now. There's never any data in them, so we're not concerned. But there's this, obviously, anytime you have an incident, you want to respond correctly and take corrective action so that it never happens again, and that's now been put in place. We also employ 2 very sophisticated software tools that help us do penetration testing and help us really understand where any weaknesses may be before code actually is allowed to be promoted into production.
So for those in the HIPAA space, you're required to do a HIPAA risk assessment once a year as one of your compliance methods. Find a really good company who's going to beat you up and find every little hole. It's painful. Prepping for them can be painful, if it's especially your first one. Our first one was a 2-week period. Also, review what you get back. Some of our executives had made decisions that, this came back and you're like, well, yeah, the standard says that, but for what we do, we're not quite there. We document, we signed off on it, and we have it on file. But make sure you get that HIPAA risk assessment, because it's good to get dinged and find it that way than find it through a DDoS attack or another method.
Just one other comment. For those of you who didn't raise your hands on the incident response plan, you're going, I don't even know where to begin. It's just like, what is that? What is an incident response plan? That's someone else's responsibility. NIST has a really easy to read publication. I think it's 800-6-1. If anyone shaking, I think it's 6-1, which is basically how to respond to a security incident. And it's really easy to read. The approach is simple to understand, and you just sort of fill in around it, create for your own typical environment, and then you create the processes around it. But it's real. NIST, I think it's 6-1, if my memory serves me correctly. That's where we started, because there really was it is 6-1. There was really very, very poor publicly available, because they tend to be proprietary, response plans, or they don't exist at all.
FEMA actually has a 3-part webinars around incident response plans and command prompt teams. It feels very governmental, but it's very organized, and there's free webinars out there. They're 3 hour plus each. So they are a little painful, but if you just download the whole thing, you can get through it faster. But they were something that we required all of our incident plan writers and people who were going to be involved with incident writing to go through this year and make sure that they came up to speed with all of the piece parts.
Right, and finally, the Department of Education's, again, Privacy Technical Assistance Center has like sample disaster response plans, sample security incident management plans that are specific to the education industry and FERPA. So if you are concerned about FERPA compliance, you can look at that. Yeah.
So for those that don't know, I often find, especially working with education and government customers, folks don't know that you can actually do penetration testing on AWS. Logically, it doesn't seem like it makes sense, but it's actually something that we do allow customers to do. There is an authorization process that you have to go through, which basically tells us what it is that you're planning to do, from where you're going to be coming from, and what resources that you're going to be leveraging, as well as some rules and let's call them guide wires that sort of point you in making sure that you're not going to do something that would impact other customers. But to Gerard's point, one of the things that's really important from an incident response perspective is that in your account right now, in the contact section, there is a contact for who is your security contact. AWS has amazing tools on the back end that help secure our infrastructure and help keep customers safe. But the only way that we can tell you that something is anomalous in your account is if we have up-to-date, proper account information in there. And oftentimes what I like to tell customers is don't put an individual's name into that field. Use an alias or an account that distributes to multiple people, because it's all well and good that today the contact is Brad, but what happens if I move on or move to another position within the company even? It's important that basically multiple people are on that list, so that if something does happen and you forgot to update that contact, at least everyone will still be alerted to an incident and hopefully to be able to remediate it quickly.
Yeah, we link it to our PagerDuty accounts, so someone gets paged.
Awesome.
Yeah, ours is production support to distribution list.
We use PagerDuty also.
Cool. So Gerard, you touched on something I think is really important, which is when looking at things like incident response, the buzzword right now is DevOps and DevSecOps. But really what it comes down to is actually testing that the product is going to do what you think it's going to do and in a controlled way, and actually sort of fuzzing the application, as it were. Can all of you talk a little bit about any of the techniques maybe that your organizations use to vet an application or a workload prior to going into production on AWS? So for Coursera, I know that you guys have some really cool tooling that you've built, but it would be interesting to hear about any of the techniques that you have for actually validating.
Right. So Coursera. For Coursera, we do we do blue-green deployments, and we basically can isolate a part of our, say, if you are deploying on. So we run a services-based architecture. So we can do things like route, for instance, user 1, 2, 3, and 4, 5, 6 to this new service that we are testing, and route everyone else to the old service. And we can then hand these user accounts to our pen testers or to our white hat hackers, and then they can validate, for instance, whether this new service is secure, whether these new APIs are secure. So we do have that capability, and that comes from, we, like the infrastructure team, which I'm part of, mandates that we use a common framework. Basically, we use only Scala on the JVM for all our backend. We use one common AMI, and we have our own custom deployment tooling that's built on top of ASGs and AMIs, so that everyone basically has one single. Basically, we don't have to do a lot of work to enable these sort of capabilities, such as or even just shifting, for instance, 1% of traffic to a new service to do a load test, for instance. So we do have that sort of capability internally within Coursera to help us validate our deployments.
We're also moving to blue-green with a lot of our regulations, especially around the laboratory stuff. The amount of regression testing we have to do and validation's pretty heavy. You also cannot do continuous integration kind of in a HIPAA world. The regulations aren't quite there yet. So we do much more, 2-week sprint, deploy type models. But there is a lot of documentation of testing, and my auditors, when they come in, still want to see that printed Excel with somebody who signed off that, I clicked here and this happened, and then I clicked here and that happened. So ours is still highly manual. We are working a lot more in the automation, at least in the code reviews and deploy part of it. But when it comes to the end user applications, especially around the medical record pieces in the clinical, that we do still do a lot of manual.
Besides the normal agile testing environment and this, the various sprints and promotions through the various instances that we have, and I honestly don't remember the name of the tool, but we use an automated code review tool that allows us not only to look at does it have any weaknesses in it for the typical security flaws, but we also use a tool in AWS to make certain that our environments are set up correctly. And what we learned very quickly was, one wrong maybe or overlooked configuration can open a hole that you didn't really know about. And we use several tools to help us manage the configuration. We use ours as a total container approach. So we use several tools to help us actually point out where are the weaknesses in the configuration that we plan on deploying, and then we use code review tools on top of the manual testing processes as we promote software through the various environments before it gets promoted into production. Love to do more, and we probably will do more over time as our applications grow and the sensitivity of what we put up there grows.
And my background before joining AWS was in healthcare, and it always made my eyes bleed slightly going to see sequencers or chip readers that were still running like Windows 2000, and you found out it was like on a public network, and it was just like a recipe for awesome, or worse, it was like a scanner of some sort. So it was always very frustrating, and I can sympathize with the fact that the difficulty there is that basically the equipment is certified for a particular moment in time, and to deviate from that causes great strain from the producer's perspective.
Well, in genetic sequencers, this isn't like mobile phones. They don't come out all that often. And so they are kind of stuck in one spot. You might get a code upgrade here and there. But I had to replace a specific printer for one of the tests, and they don't make it wireless. So I had to deploy a computer to put a new printer out because I had to hardwire it to a machine. And that was the new model. So there is still a lot of the instruments that I worry about. And with the sequencers, they are not on the internet. They're just on the direct connect. And so keeping them off the network has been important, but being able to get that data off quickly. We were in the world of transporting hard drives. And so the direct connect was a great change for us. My corporate network, I just couldn't get fast enough to be able to run our VoIP systems, our email systems, and you could tell when the sequencers were done for the day because everybody's email was slow. So we had to put the direct connect in. We can also do a lot more in timing things, which has greatly helped in terms of speed and compliance and making sure our data is going to the right place so nobody just put it to the wrong Samba share or moved it to a different network. There's no other option. The only option is to get off and go to a safe place in a safe manner.
So when we look at things like, to Gerard's point around, testing and actually looking at how software is deployed in detection, AWS offers a number of tools that can help you do detection of anomalies in your network. So if you don't know, services like config and config rules can not only alert you that something has been misconfigured or is non-compliant with a policy, but can actually go and remediate that miscorrection or basically address that vulnerability. And then for environments that maybe are a little bit more hands-off, you can use tools like Trusted Advisor, which gives you some services off the bat for free, as well as if you have higher levels of support, give you additional checks that you can use as well to get deeper insight into how is my environment actually configured, both from a security perspective, but also from a cost and performance perspective. So when we look at how you use tools that are AWS native, is it safe to say everyone uses services like CloudTrail and CloudWatch? And can you talk a little bit about any special sauce maybe that you've used on any of those?
Don't think we have special sauce.
We don't. One of the things I've been looking at is definitely look at AWS Partners and additional software. While there are some great native tools, sometimes digging into them with the native tool isn't the best. So we do, we use Cloud Health right now to help on cost optimization and doing some tracking and alerting. So, I'm sure the expo hall is going to be full of them in a couple of hours. But check out different partners, and everybody's got a little nuance. We go through a yearly vendor review on this, specifically because things have changed so much year over year that my vendors are on notice that there's other people out there who might have done something cooler this year that may help us keep costs down, keep tracking, keep our configs better, faster, and cheaper.
Right. So we also use CloudTrail and CloudWatch and things like that. And for our CloudTrail information, we actually import that into a third-party vendor. We use ThreatStack, but as Elizabeth said, there's probably like 100 vendors out there in the expo hall that do similar things, and then they provide like a sort of singular view of what's happening in our stack, who updated, say, created a new security group, or who for ThreatStack, they also have agents that we can install on our instances, and then they can tell you, who logged in, what commands did they run, and things like that. So it provides like basically alerting and also an audit log of who did what when. Yeah.
One differentiating factor, I think, in the CJIS world is there are hundreds and hundreds of requirements beyond just the infrastructure. So the applications, if you're familiar with anything in the NIST environment, there's requirements that will dazzle you over, and we've got to meet all those. So we spend, I would say, a lot more time once we get a solution architected is being certain the application we built on that infrastructure and that architecture actually meets the requirements. And that's everything from the complexity of the password to the number of times the password has to be changed. I mean, very, very detailed requirements were required to meet on top of the infrastructure controls that we have to have in place. So we utilize the native tools to help us in that environment, which is one of the reasons for choosing AWS over other providers, just the degree of automation and the degree of tools that are available to help us in the mission. Because having to create all that stuff from scratch would be just impossible. And a lot of the CJIS requirements for logging and audit trail are just come natively in the environment. We can use them. But and we do spend a ton of time on the application stack itself, because we're confident in what we can get from AWS. We've already reviewed all of it, implementing those tools, and then the application stack, it's on us. And that's a huge piece of work to make certain we meet those requirements.
To your point, when you're trying to meet your requirements, if you're going to use a third-party vendor, make sure they can also meet the requirements. For example, in HIPAA, again, we've got a limited set of tools we can use. And there's some great vendors out there doing great things, but they won't sign a business associate agreement, or they want to take all my data and put it in their AWS side of the house, which I have no control over. So there's vendors where I've just had to stop the conversation because they can't meet the same requirements, even though they're doing great, cool, awesome things, and I'd love to use them. So this is my vendor plea: is think of healthcare. We're growing. We're using the cloud. Meet our requirements too.
Right. Same thing with because we handle a lot of international data. For vendors out there, make sure you're compliant with Safe Harbor, or make sure that you're compliant with various EU directives and things like that as well.
So to my earlier point, when I said that all of these compliance packages and frameworks have overlap, one truth among all of you is that really at the core of FERPA, I want to know who has access to my student data. At the core of FERPA, I want to know, or HIPAA rather, I want to know who has access to my patient information. And for CJI and CJIS, who has access and who has accessed my CJI data. So when we look at services again like CloudTrail, the ability to do things in a sort of macro level, to know not only from a GUI perspective what's taking place, but also from a software level what's taken place. So for folks that don't know, everything that you do on the AWS platform is actually an API call. So when you're working in the sort of front GUI environment as you're clicking around and taking operations, every single thing that you've done is actually an API call in the back end. And services like CloudTrail can actually ingest all that information, and then you can use third-party tools to help get deeper information about not only what actually transpired, but you can also build your own automated tooling around that to do incident response. And a really good example of that is there was a blog post that we put out about 2 months ago that talks about how to basically configure an environment to auto-remediate an incident response. So basically an instance maybe has gone rogue. We can automatically deprovision that instance, but get it set up so that we can do automated incident response for things like EBS snapshots or memory acquisition, or putting it into a safe space so that our forensic investigators can go and actually analyze that data. So when we think about looking at sort of the data stream and all of your accounts, do you leverage any sort of log analytic tools like Splunk or an Elk Stack? And where do you see any sort of shortcomings in that space?
So basically, we take a similar approach to AWS with our application as well. So every single action that anyone does on Coursera is an API call, and we log all of that, and that actually gets shoved into a Kafka stream and then we build like custom solutions on top of that. For instance, if you are making too many requests or too many bad requests to a specific endpoint, then we'll actually block your account or block your IP for a set amount of time, and email someone or alert someone. So that is so on the automated side, that is sort of what we do, and on the manual side, we actually use a competitor to Splunk called Sumo Logic that basically aggregates all our logs, and we have like custom searches that run hourly to alert us to any sort of anonymous API calls and anonymous behavior across all our systems.
We use native AWS tools, plus we wrote our own complex audit logging software because we have to log things at the application level with very specific requirements. There's, I think, 8 or 9 specific requirements with 7 to 10 pieces of data you got to log on every event that takes place at the application level, which we had to put in our application. Which we've been doing this within on-premise systems, so we knew we had to do it. We knew how to do it, and we wrote our own and logged the data to a database so we can report on it as part of the requirements. And then standard AWS tools for the logging of infrastructure data.
Ours isn't too sophisticated. We have obviously all the tools around S3, which is really holding all my data, and then we have an electronic medical record system, so they really take care of most of that access point, tracking who accessed which patient record, how long, when, all that kind of stuff. So we don't do as much in our own internal analytics other than who pulled the S3, be it an API or a person.
So as part of the access control that goes for each of your compliance packages, so again, at the end of the day, I really want to know who has access to these components, but another component is restricting that access. And that could be something like an access control list or a restriction, or it could be encryption. For encrypting data that you're using on the platform, do you find that you're using native services like KMS, or are you doing more client-side encryption before the data goes to AWS, or a mix of both?
We actually created, because we have to follow FIPS 140-2 requirements for encryption in transit, Modules have to be approved under the NIST guidelines. In the upfront load balancers were only compliant for administrative actions. We actually deployed our own set of services and encrypt once it gets for encrypt. We deployed our own set of services for the data coming in transit. So it's encrypted in the browser across the network to our own set of custom services that we had. We secured our own certificate from NIST, which I believe is based on OpenSSL. And then we also have encryption at rest. So everything that's encrypted in storage and also between VMs is all encrypted in transit inside the VPC. It did take a while because GovCloud encryption and FIPS, it took a while to understand. Although endpoints are listed as FIPS 140-2 compliant, what are they uncompliant for? Is it for administrative actions or your data going through those endpoints? And when you get to talk to the right person, you learn which of those endpoints are both and which are just for API administrative calls as opposed to data. And once we got past that, we set up our own custom encryption engines through basically EC instances, and we're able to meet the requirements of the FIPS for in-transit and at-rest encryption.
For us, we try to use Amazon KMS where possible. So for RDS, for EBS, we try to use Amazon encryption. But for instance, we run Cassandra as our key value store on instance storage, and in that case, we'll have to basically use Cassandra's native encryption. But we try to. For us, our requirements are not as stringent, so we try to use KMS as much as possible.
Ours is encrypt at transfer and rest per HIPAA, but mostly client side. We've been looking at trying to get KSM in. It's one of those fun things where I have so few resources, but fighting for a new application or putting KSM in, so it keeps getting deprioritized on our list.
So in the remaining minute that we have left with the audience, I'm curious, for all of you, if you had a peer that came up to you and said, I really would like to go to the cloud and start doing this, but I don't know where to start, what would you say?
In healthcare, I tell people do pilot projects. Find somebody's sacred cow that they love and they want really badly and do that. Because you're going to get a really good champion who's going to be involved and get it done and then tell people that they got what they wanted, which is a really great marketing tool.
I would say in public safety, don't start with CAD. Computer-aided dispatch it's life and death. It's instant. It has to be instantaneous response. We're talking sub-second. Start with something that is less instantaneously critical, something that you can have a success at quickly. You can be successful with CAD, but you've got to architect it to be sub-second response time because that's what operators in the call center and 911 center, they're used to it happening in sub-second. And as we know, network latency can make that disappear pretty quickly. Start with something that you can be successful at. In our case, we started with a place we knew would have huge amounts of data, and that was body-worn camera, video management, and a place that the cloud could help us significantly. And we moved into mapping and other areas that allowed us to use cloud resources and where we needed to scale. Start with something that allows you to be successful, but not put the farm at risk if you run into problems.
For our university partners, it will be talk to your professors, talk to your lecturers. Chances are they are already using AWS, so so in your universities, you'll probably find people already probably pretty well versed in the cloud world. So go talk to basically your faculty. Yeah.
Great. So I want to thank all of you guys for coming out and coming to the session today. The panelists, I think, can stay for maybe just a moment to answer any questions individually that you have. But otherwise, we want to thank you guys and have a great show.